We're going to talk about how to find the equation of a parabola. Now, in grade 10 or at the grade 10 level, there are two main options based on what you are given. But regardless of what you're given, at the end of it, you should have an equation that looks like this. The end goal is eventually to get the value of A and the value of Q. However, the way it's achieved is different. The first option is only applicable in this condition if you are given the y-intercept and any other point. So given the y-intercept and any point, use option A. The method is you substitute the y-intercept for the variable q and you substitute the point to solve for the variable a. Let's have an example. We have this on the screen. Our equation for a parabola is y is equal to ax squared plus q. Now, if you notice, we are given the y-intercept and one other point. So we're on option A. The y-intercept, as the instruction says, we need to just take this and substitute it for that. So the equation stays the same. Y is equal to ax squared. And for q, we're going to have minus 4. The second part says to take your point, which is this here, and to substitute it into that. Now, this is an x and this is a y value. So it's 5 for your y value. 5 is equal to a. In place of x, we're going to have negative 1 squared minus 4. Now, we just need to solve this equation. Negative 1 squared is positive 1, so it's just a minus 4. And we got 5. Now, if you go ahead and try to solve for a, you're going to move the 4 across, and it's going to become a plus 4. And 5 plus 4 is 9. Once you've solved for a, as step 2 says, it's just a process of taking your answer and putting it back into this equation. So in our equation, y is equal to ax squared plus q. We now have the variables we need. So we'll say y is equal to a, we said is 9, so 9x squared, and q we said is minus 4. And this is our function found. So all we have to do is take our y-intercept, put it for q, take our coordinates, substitute it for x and y, and then solve for the variable a. Once a is found, put it back into the formula, put a and q back into the formula, and write your final answer. That's option A. Option 2 is a bit different. This is if you are given the 2x intercept. So now we're not given the y-intercept, we need the 2x intercept. Now, because the parabola is symmetrical about the y-axis, so if you are given one x-intercept in grade 10, you know the other x-intercept is just the negative of that, just if you change that sign. So in grade 10, if you are given one intercept, it's as good as being given two x-intercepts. And you need one other point. The method is a bit different. You have to use this equation. This is called, or I call it, a roots equation. I don't know if it's actually called a roots equation, but the reason it's being called that right now is because x1 and x2 are the roots, and the roots of a parabola are basically the x-intercept. So in our functions, we call the roots the x-intercept, okay? So the x1 and x2 are our two roots. So we take our roots equation, we substitute the x-intercepts for x1 and x2, and then we sub a point and solve for a. So this is the same as the first one, but the solving is a little different. Let's go ahead and begin. So our equation is given, so our picture is given. Negative 2 and 2 clearly are your x-intercepts. This is a coordinate, so we're good to go with option 2. So y is equal to a into x minus x1, x minus x2. we're gonna take these two values and substitute them in. So y is equal to a into x minus, the first root is minus 2, okay, and the second root is, well, just 2. If you simplify that brackets, you get a into x plus 2 and x minus 2. Now at this point, I would recommend you take this and substitute that in there. Now your y value is negative 15 equals to a into your x value is 3. So 3 plus 2 brackets, again your x value is 3, 3 minus 2 brackets. So we can say negative 15 is equal to a, 3 plus 2 is 5, and 3 minus 2 is 1. So negative 15 is equal to a times 5 times 1, which is 5a. Divide both sides by 5. A is equal to negative. It's equal to negative 3. We can then go ahead and take this value for a back to where we substituted the coordinates in. All right, so that last coordinate we substituted, and then you're going to take that y is equal to a into x plus 2 x minus 2. Now remember I said I'm going to put this here, so erase that, and that's negative 3. And then you can say y is equal to negative 3. Now I'm gonna apply FOIL here. I'm gonna do the product of two binomials. So that answer is going to go into a bracket and be multiplied to negative 3. But let's FOIL that out. And then you should get x squared. You should get x squared minus 2x plus 2x minus 4. Right? If you look at plus 2x minus 2x, those like terms will cancel, so you'll be left with x squared minus 4. Y is equal to negative 3 into x squared minus 4. And lastly, we're going to distribute this into the brackets, and our final equation is y is equal to negative 3x squared plus 12. And then we've got our ax squared plus q situation. So we ended up with the same thing, but it was just a different process. Now this method is a little trickier because there's a lot more steps, there's a lot more to do. It's a bit of a back and forward process with that. Now what you're going to need to do is make sure you practice this, okay? You have to practice this one, especially with the 2x intercepts. You've got to remember, take the two x-intercepts, put them for x1, x2, simplify, substitute a coordinate and solve for a. Take your a back into that equation and simplify the entire thing to get your final answer, alright? You can go through this video a couple times just to make sure you know the process. In fact, if you just ignore all of this and try the whole question again, try it yourself and see where you get stuck and just check it again. An important idea that you need to know and master, really important. So don't take it for granted that it's easy until you've done it yourself without looking at a question or without looking at a memo, an answer, or someone else's work.